Hi friends, today we will be solving problem 1 in synthesis method. We are given that design a 4-link mechanism if the motions of the input and the output links are governed by a function y is equal to x power 1.5 and x varies from 1 to 4. Assume theta to vary from 30 degree to 120 degree and phi from 60 to 130 degree. The length of the fixed link is 30 mm. Use Chebychev spacing of accuracy points. So to solve this problem, we will require two equations. The first equation is Freudenstein's equation. There is also Chebychev spacing equation. To begin the problem with, we will solve by finding the values of x1, x2 and x3 using the Chebychev spacing equation, where for finding the value of x1, xn plus 1 is the final value in the range. We are provided that x ranges from 1 to 4. So the value of xn plus 1 is going to be 4 plus x0. The value of x0 is where it begins from. It is 1 divided by 2 minus xn plus 1. It is 4 minus 1 divided by 2 into cos of 2i minus 1. I is the value of the term of x. So here it is x1. We are going to multiply it with 1 minus 1 into pi divided by 2 into n. Here the value of n is 3, as we are going to consider it for x1, x2 and x3. So the value of n is going to be 3. Similarly for the value of x2, x2 is equal to, the first two values are going to remain the same, as it is not dependent on x1 or x2 or x3. Similarly for the value of x3, after finding the values of x1, x2 and x3, we have to find the values of y1, y2 and y3, for which we will be using the equation that is provided in the question, which is y is equal to x to the power 1.5. So after substituting the value of x1 in the equation of y1, which is y1 is equal to 1.2 power 1.5, we get the value of y1 as 1.315 approximately. Similarly for the value of y2, 2.5 power 1.5, which is equivalent to 3.953. For the value of y3, 3.8 power 1.5, y3 is 7.408. Similarly, we have to find the value of y0 and yf using the range that was provided in the question. So y0 is going to be x0 to the power 1.5 and yf is going to be exf to the power 1.5. In our case, y0 is equal to 1 to the power 1.5 and yf is going to be 4 to the power 1.5. y0 is equal to 1, yf is equal to 8. If it is asked in the question to find the range of y and the range of x, we will be using this formula. Range of x is equal to xf minus x0, which is going to be 4 minus 1, 3. Range of y is yf minus y0, which is going to be 8 minus 1, 7. For finding the values of theta 1, theta 2, theta 3 and phi 1, phi 2, phi 3, we will be forming equations with the values that are provided to us. Theta is equal to ax plus b. Similarly, phi is equal to cy plus d, where theta naught is equal to ax naught plus b. In our case, theta naught is going to be 30 degree, is equal to a into x naught is going to be 1 plus b. Theta f is equal to a into xf plus b, which is going to be 120 is equal to a into 4 plus b. Marking this as equation 1 and this as equation 2. As in these two equations, there are two unknowns, so we will be able to find it. A is equal to 30 and b is equal to 0. Similarly, for the value of phi, we will be equating phi naught is equal to c into y naught plus d. 60 is equal to c into 1 plus d. Similarly, phi f is equal to c into yf plus d, which is going to be 130 is equal to c into 8 plus d. As there are two equations with two unknowns, we will be able to find the value of c and d. C is equal to 10 and d is equal to 50. After solving, we get the equations for theta and phi. Theta is the degree for input link. And phi is the degree for output link. Now, with these two equations, we will be substituting the values of x1, x2 and x3 and y1, y2 and y3, and we'll be finding the values of theta 1, theta 2, theta 3 and phi 1, phi 2, phi 3. Theta 1 is equal to 30 into x1, which is going to be 30 into 1.2, which is 36. Theta 2 is equal to 30 into x2. Here 30 into 2.5, which is 75. Theta 3 is equal to 30 into x3, which is going to be 30 into 3.8, which is. After finding the values of theta 1, theta 2 and theta 3, we will be finding the values of phi 1, phi 2 and phi 3. Phi 1 is equal to 10 into 1.315 plus 50, which is 63.15. Phi 2 is equal to 10 into 3.953 plus 50, which is going to be 89.53. Phi 3 is equal to 10 into 7.408 plus 50, which is going to be 124.08. In our case, it is k1 into cos 63.15 plus k2 cos 36 plus k3 is equivalent to cos of 36 minus 63.15. This is our first equation. K1 cos 89.53 plus K2 cos 75 plus K3 is equivalent to cos of 75 minus 89.53. This is our second equation. K1 cos 124.08 plus K2 cos 114 plus K3 is equivalent to cos of 114 degree minus 124 degrees. This is our third equation. For finding the values of K1, K2 and K3, we will be using Cramer's rule, or we'll be using calculators to find the values of K1 and K2 and K3 using simultaneous equations. With these three values of K1, K2 and K3, we will be using the Freudenstein's equation and will be finding the values of A, B, C and D, which are the link lengths of the 4-bar mechanism. The equation is K1 is equal to D by A. We are given that the length of the fixed link is 30 mm. So D is equal to 30 and we have to find the value of A is equal to K1. We know that the value of K1 is 2.286, which is equal to 30 by A. So A is equal to 30 by 2.286, which gives A is equal to 13.1 mm. Using the second equation, which is K2 equal to minus D by C, where we know that the value of D is 30. So minus 30 divided by C is equal to minus 1.98. From this, we will be able to find the value of C, which is 15.2 mm. K3 is equal to A square minus B square plus C square plus D square divided by 2 into AC. So from these four variables, we know the value of A, we know the value of C, we know the value of D. The only unknown here is B square. So to find this, we will be substituting the values of all the remaining variables, which is 1.461 is equal to 13.1 square minus B square plus 15.2 square plus 30 square divided by 2 into 13.1 into 15.2, which gives the value of B as 26.84 mm. Hence, we have found all the values of the links of the 4-bar mechanism. See you in the next video. Till then, bye from Vettri Academy.